All right, let's talk about something that can feel a little intimidating: home electrical work. Now, this isn't about turning you into a professional electrician overnight, not at all. The goal here is to build a solid foundation of safety and understanding. We're going to give you the knowledge you need to tackle some simple tasks with confidence, but also with a huge amount of respect for the power that's literally all around you. So, let's dive in.
So, here's what we're going to cover. First up, the single most important rule in all of electricity. Then, we'll get into how it all works, understanding the flow. After that, we'll look at the parts of a circuit, cover some key rules of the road for installation, and finally, we'll talk about knowing your limits. Pretty straightforward, right? Let's go.
Okay, Section 1, Electricity's One Golden Rule. And folks, I can't stress this enough. This is the single most important concept in electrical safety. We're starting with this for a reason. If you take away only one single thing from this whole explainer, please let it be this. So I'm going to ask you directly, what do you think is the absolute #1 non-negotiable rule of all electrical work? I mean, before you even think about touching a wire, what's the first thing that should pop into your head? There it is. Never assume a circuit is dead. This is it. This is the golden rule. You just can't trust your assumptions, ever. And you might be asking, why? Well, think about it. A breaker could be mislabeled in the panel. That happens all the time. A switch might be wired incorrectly. Or heck, someone else in the house could just flip the breaker back on, not knowing you're working on it. Making assumptions is, without a doubt, the most dangerous thing you can do. So how do you follow that rule? You use this simple 3-step safety procedure. First, you de-energize the circuit. That means you go to the breaker box and flip the right breaker to off. Second, you lock it out and tag it. This physically prevents anyone from flipping it back on. And third, and this is the most critical step of all, you verify. You take a multimeter or a voltage tester and you physically test the wires you're about to work on to prove there's no power. You don't guess, you don't hope, you prove it. All right, Section 2, understanding the flow. We've got the #1 safety rule down. Now let's get into the basic science behind the power in your walls. Trust me, understanding how this stuff works is a huge part of respecting it and working with it safely. Okay, first concept, electric current, which we measure in amperes, or just amps. The best way to think about this is like water in a pipe. The current is the amount or the volume of water flowing through that pipe. It's the actual movement of electrons, and really, this is the part that can be dangerous. So, if current is the water, what's making it move? Well, that's voltage. You can think of voltage as the water pressure in the pipe. It's the force, the oomph, that's pushing the current along. No pressure, no flow. It's that simple. And that's why high voltage signs are so serious. It means there's a ton of push behind that current. And that brings us to the third piece of the puzzle, resistance, measured in ohms. Sticking with our water pipe analogy, resistance is like a narrowing or a clog in the pipe. It's anything that makes it harder for the water to flow. So you've got voltage, the pressure, pushing the current, the water, and resistance is what's pushing back. For example, a copper wire has super low resistance. It lets current flow easily. But the tiny filament in an old light bulb, it has really high resistance, and that opposition is what actually makes it heat up and glow. And this idea of resistance leads us to a really important distinction between two types of materials, conductors and insulators. It's pretty simple, really. Conductors, like the copper or aluminum in wires, have very low resistance. They're like wide-open pipes that let electricity flow without a fight. Insulators are the exact opposite. Things like rubber, plastic, even wood, they have super high resistance. They're like a solid cap on the end of the pipe. And that's why we wrap wires in plastic, to keep the electricity where it's supposed to be and to keep us safe. Okay, on to Section 3, the anatomy of a circuit. We've got the big safety rule, we've got the basic science down. Now, let's pull back the curtain and look at the actual parts that make up a circuit in your home. So when you boil it down, pretty much every circuit has these 5 key parts. You've got the source, which is your main electrical panel. Then you have the protection, that's your circuit breaker or fuse. The electricity travels through conductors, which are just the wires. It goes to the load, that's the thing doing the work, like a lamp or a TV. And finally, you've got the control, which is usually a switch that lets you turn it on and off. Source, protection, conductor, load, control. That's the whole loop. All right, here's a super practical rule you've got to know. The code says you need to leave at least 6 inches of wire sticking out inside any electrical box. And there's a really good reason for this. It's not just a random number. That extra length gives you enough room to work comfortably and make really solid, secure connections. Plus, if you ever need to come back and fix something later, you'll have wire to work with. If you cut it too short, you're making the job way harder and honestly a lot less safe.
Okay, this one is a big one. It's an absolute no exceptions rule. All junction boxes must stay accessible. That means you can never, ever bury one behind drywall or tile or anything else. Why? Because every single place where wires are connected is a potential point of failure. Wires can come loose over time, and that can cause sparks or even a fire. You have to be able to get to that box to inspect it and fix it if needed.
Moving on to Section 4, Rules of the Road. Think of these as the key best practices that ensure an electrical installation isn't just working, but is safe and going to last for a long, long time. Let's look at a few of these key rules. First, cable securing. You've got to staple down your wiring within 12 inches of a box, and then every 4.5 feet after that. This keeps the wire from getting yanked and putting strain on your connections. Next, hole setbacks. When you drill through a stud to run a wire, that hole needs to be at least 1.25 inches back from the edge. This is huge. It protects the wire from getting hit by a random drywall screw later on. And finally, grounding. Every metal box, every switch, everything has to be grounded. This provides a safe path for electricity to go if there's a fault, which trips the breaker instead of electrocuting someone. Each of these little rules adds a crucial layer of safety. And that brings us to our final section. And honestly, it might be the most important one of all. Section 5, Know Your Limits. It's about knowing when to give something a try and when to pick up the phone and call a professional. This is not about ego, it's about safety. So what does it mean to be an electrically skilled person? Well, here's the formal definition. It's someone with the right skills, training, and expertise. Notice it's all three of those things. This is a qualification that's earned through thousands of hours of training and real-world experience. It's definitely not something you pick up from watching a few videos online. So let's draw a really clear line in the sand. For a beginner, your focus should be on safety, understanding how things work, and maybe doing very basic maintenance, like swapping out a light switch on a circuit you have confirmed is dead. But the moment you're talking about installing a whole new circuit, doing anything inside the main panel, or dealing with the service from the street, that's electrician territory. No question about it. That's work that requires a license and a permit for a reason. And so, we're going to end right back where we started, with this one critical question. Is this circuit truly off? And more importantly, how would you prove it? Remember, it's never, ever about guessing. It's about testing and proving. Your safety is in your hands, and it all comes down to being able to answer that question with absolute 100% certainty. So please, always, always verify.